Hello, Algebra 1 students, and welcome to Lesson 3.3 in our Linear Functions section. You might recall that Lessons 3.1 and 3.2 really focused on what was a function and then some function notation. 3.3 and 3.4 kind of bring us back to what we did last unit, which was a lot of graphing. One thing we didn't do a lot of last unit, though, was writing equations from a graph. So a lot of times we were given an equation in HK form or slope-intercept and said, graph that equation. But we didn't go the other way around. And so what we're going to focus on today and next class are really writing and comparing different equations to each other. So for our opener, we have a single line over here. Your goal is to decide which of these answer choices match the line. And when I say match, I really mean create the line. And so just to give you a quick example, if you were just looking at A, if you wanted to check to see if A matched your graph, then I would probably graph this equation, right? And I'm going to kind of turn this sideways. It's a little bit harder for you guys to see. But we need to notice that A and B are in a particular form. They're both in that form of y equals mx plus b. And so if something is in the form of y equals mx plus b, we should be able to identify the b value, which is our y-intercept. And we'd say, okay, if I put -3 on the graph right there, that matches so far. And it matches because the y-intercept is on the line. And that's important. It has to be. And then we check the slope up to over 1, right? This is our m in the mx plus b. And it tells us to go up to over 1, and we've found another point on the line, right? These directions, this movement needs to match up to the line every time, and it does. So because when I graph this equation that I've done in red, and it perfectly matches the line that's already done here, then we would say that A is certainly an equation that matches this graph. Now the problem is that there could be more than one equation, and so your goal is you're going to have to look through and try and graph each one of these. Now, A and B are in slope-intercept form, and we did those earlier on. This was lesson 2.2 if you need to go back and review it. C and D are in HK form, mx minus h plus k, and that was lesson 2.3. And then our last two, E and F, are not in either of those forms, and you might want to have to go, or you might go back to lesson 2.4 to figure out how to graph those. So go ahead and pause this video, see which ones of these do match the graph, and then unpause to check your answers. Alright, welcome back. Well, it turns out that actually all of these match the graph. Now, if you were able to show work and prove that all of these do match the graph, then you can probably skip this section and move on to the lesson for today. If you struggled a bit, though, with any of these, you might want to listen to my walkthrough about how they match. So if we look at B, notice on B, instead of starting with y, and I'm going to clean this up a bit, instead of starting with y like I did on A, on B I started with f of x. And remember that these two are really interchangeable with each other. So the y and the f of x don't make a difference, right? Instead of y equals mx plus b, it could have been f of x equals mx plus b. No difference there. And I said that this was an mx plus b, but we always like to write the m, the number that's multiplying by the slope first, and then the b at the end. So as we go through and graph this, we again start at -3, that's my y-intercept, okay? And then from there, we need to go through and use the slope. My slope says to go up 6 to the right 3. Up 1, 2, 3, 4, 5, 6, to the right 1, 2, 3. And I think that ends back up on the line. Because these 2 points are on a line, we say that they're collinear. You can connect them, and it does match the graph. Great job. You could have also realized that 6 over 3 actually reduces to 2 over 1x minus 3. And so it's actually the exact same equation as A. Let's look at part C. Part C and D were in HK form. And the key to understanding HK form is realizing that there is a point given to you each time. Here is my first point. Here is my second point. So on part C, if I look at this point, it looks like it should be the point -2, +1. But the weirdness with HK form is that that negative, or whatever value is inside, always becomes the opposite. So this should be the point 2, 1. Let's see if there's a point 2, 1 on my graph. We go over 2, up 1. Here is the point 2, comma 1. That's on my graph. Good. Then we check the slope, which is up 2 over 1, and that matches up. So C is also correct. So A was good, B was good, C was good. Let's check D. All right? Opposite of H, so -1, and keep K the same, which is -5. -1, -5 is my point right here. That is on the graph. It's a good start. And then the slope, up 2 over 1. And look at that. We are also still on the line. D works. Now, E and F can be a little bit trickier. E, to me, seems like it won't be too hard to isolate Y to put it into slope-intercept form. So let's do that. All right, I'm just adding 2x to each side. You could either put the -3 first and then the 2x, or the 2x and then the -3. And because I'm going with mx plus b, I want to put probably that number multiplying by x first, and then the -3 at the end. Right? So if we look at this, I think this equation is exactly the same as part A, so certainly that one has to match. The last one is definitely, as I mentioned, a little challenging. You could find intercepts. You could replace the x's and y's with zeros. It's not too terrible to get y alone, though. I think one thing we could do is subtract 6 from each side. That will give us 4x minus 6 equals 2y. And then to finish isolating y, we divide everything by 2. And don't forget, when we multiply or divide, we do have to distribute that multiplication or division. So I'm going to distribute dividing by 2 to both of these, which gives me 2x minus 3 equals y. And I think that is exactly the same as E and A, and so F will match as well. If you wanted to quickly check this using Desmos, what I did is I set up all the graphs from the opener over here, and as I turn them on one at a time, you'll notice that the colors just overlap each other. There we go. And the next one, and the next, and the next. Every single one of these makes the same line. So let's jump on to our lesson for today. Okay? We're going to focus on creating or writing an equation that matches a given line. Now, our two common forms for an equation are slope-intercept form, which hopefully we'll remember is y equals m times x plus b, and hk form. That's the y equals m times x minus h plus k. Now, both equations are created using a slope and a point. For example, in y equals mx plus b, we have, of course, the slope. That's not bad. And then the point that's given to us is the y-intercept. That is a point. However, that can get a little bit tricky. So let's practice slope-intercept form really quickly, and then we'll come back to HK form. So jumping down, I have 3 lines down here. And we're going to quickly write these in mx plus b in slope-intercept form. Okay, so this first space is for HK form. We're going to come back to that. Let's look at mx plus b first. So with mx plus b, and I started with f of x. You could also do this with y, and I'll kind of mirror this down below so you can see the similarities. Y equals m times x plus b. M times x plus b, right? Both of these mean the same thing. So in order to create an equation from a graph, we need the slope first, but we're pretty good at finding the slope. You just pick any 2 nice points on our graph, right? There's 2 points, and we see that we fall down 1 and run over 3. So it looks like my slope is -1/3, or -1/3, same thing. And then the plus b is, of course, the y-intercept. So this is 0, 2. It's +2, so we add 2 at the end. And so we'd say our equation is y equals -1/3 x plus 2, or -1/3 x plus 2 equals f of x, same thing. So knowing that, go ahead and write the last 2 equations in mx plus b. And then once you're done, unpause this, and we'll see how you did. All right. Well, if we look at this second one, I think the slope isn't too bad, right? We have these 2 points here. Looks like it goes up 1 and runs over 2. So our slope is 1/2 x. And then on this last one, 2 easy points, here and here, it looks like it goes down 2 and to the right 3, so negative 2 over 3. What are the y-intercepts, though? Well, looking on this second graph, you'd say, well, this crosses the y-axis right here. I think that's a y-intercept of 0, comma, let's say 0.5 or 1/2. Okay, so we say it's plus 0.5. Okay, then if we look at this last one, you're like, well, where does this cross the y-axis? It's right here. You're like, well, that's not 0.5. 0.5 is kind of right in the middle. That's a little bit too high. I don't know, maybe this is 0, comma, negative 2.4. And so your y-intercept would be minus 2.4. Now, the problem with slope-intercept form is if you don't know the exact value of the y-intercept, it can be a little bit trickier to write a perfect equation. In fact, although B is correct, if you were to graph this, it will perfectly match the line. C is not correct. If you were to graph this, it will be a parallel line, but it'll actually be just a little bit lower than the one here. So what do? Well, either you find a more accurate y-intercept, or we go back and we use HK form. You'll find as you move further on in mathematics that you actually use HK form more than slope-intercept form because it's more versatile. You can do more with it. So if we quickly remind you about that HK form, just like slope-intercept form, they of course give you a slope, and then they give you a point. But the important thing about the point in HK form is that this can be any point on your graph. Slope-intercept form is limited to the y-intercept. We can use any point with HK. So let's go ahead and set these up really quickly so we can show you how fast it is to write something in HK form, and then we're good. So HK form, just a friendly reminder, has a blank, and then it'll be x, some sign, and a blank, and then some sign, and a blank. The nice part about all of these is that the slopes are the same. We already found the slope. It's at mx minus h plus k. So I know my slope here is negative 1/3. My next slope is 1/2. And my last slope is negative 2/3. All right, let's look at HK. Well, we just need a point. And I'm going to say let's not use the y-intercept. You could say minus 0 plus 2 for the y-intercept, but let's do something different just since we're practicing right now. Let's just use the other point I picked over here. This is the point negative 3, comma 3. So how does HK form work? We take the opposite of h, so it looks like minus 3, so we put plus 3. And then we take the k, which is a 3, but we don't just put the 3 at the end. I see a lot of people forget to put something here. If you don't put anything in, we assume that means multiplication. We don't want to multiply. This is a positive 3, so plus 3. And there's HK form. That will perfectly match the graph. Let's try the last two. 1/2 x. Let's fill in the blanks. Let's find another nice point on here. How about this guy right here? This is the point 3, comma 2. So opposite of h, minus 3, positive 2, plus 2. This way we didn't have to deal with any decimals at the end, and I'm 100% confident that that matches the graph. Last one. What's another nice point over here? There's a bunch of them. I think this one's actually a pretty good point down here. This is 4, comma negative 5. So opposite of h. Now plus k, you could write plus minus 5. However, a positive and a negative right next to each other just stay negative, and so we end up here. Great. HK form is very easy. It just needs a slope and a point. So we first looked at these lines given to us as a graph, but there are different ways to present a line. Sometimes you're presented a line in a word problem, sometimes in a table, and sometimes as a graph. And so we're going to practice writing equations of lines given all three of those scenarios. For example, if you're given that a line in the form y equals f of x, right, y equals stuff happening to x, and it passes through this point and has this slope, let's write the equation in HK form. And I'll try to color code this for us. Negative 2, negative 3, and slope of 3. Well, HK form takes the slope first, has this x piece. We take the h value, that's always the x, we do the opposite of that, and then the k minus 3. Hey look, this is the perfect equation where if you graph it, it will pass through that point. A lot of times, though, you are still asked to write the equation of the line in slope-intercept form. So how do we do that? Well, one way that's actually pretty easy is to realize that slope-intercept form, and I'm just going to kind of write this down below, mx plus b, slope-intercept form doesn't have any parentheses. We know that this is already a correct equation. Do we know the algebra to make it so we can drop the parentheses? And hopefully you're thinking, oh, yeah. To drop parentheses, you just distribute, and you'd be 100% correct. So we get f of x equals, let's distribute that 3. So that would become 3 times x is 3x. 3 times 2 is positive 6. And then don't forget the minus 3 that's still hanging out at the end. As we combine like terms, the 3x stays the same, which is supposed to be in blue. There we go. And then our 6 minus 3 is positive 3. And now we are in slope-intercept form. Notice that today I'm writing this f of x more than y, and that's just good practice to get you used to our f of x, our function notations, and that since that is a main theme for this unit. So I have these two equations right here, and you might think, well, they don't look the same. How are we certain that we're right? Well, and we can quickly check this. I'll show you on Desmos. And as a reminder, Desmos is a free app. You can get it on your phone. Easy way to check. So let's see, I'm going to do this and turn off the graphs there. And let's go ahead and do a few things. So here's my point. -2, -3 right there. I want both of these equations that I've boxed to pass through that point. So let's try the first one. It was f of x. It was a slope of 3. It was x plus 2 minus 3. And notice it passes through the point. Woohoo! Then we also converted this to slope-intercept form, and that was 3x plus 3. And look, it also passes through the point. In fact, these are the exact same line. Hard to see, sorry. There we go. Okay, well, what else are we going to be asked to do with these equations? Well, C and D, what are the x and the y intercepts for this line? Okay, we've practiced finding intercepts before, and this is why we're doing it again. We've got to keep it fresh in your brain. As a friendly reminder, a y-intercept always happens on the y-axis, right? Here's a y-axis, a y-intercept, and the x is always 0. So for the y-intercept, we're going to be creating a point where the x is 0, and we're finding a y. For the x-intercept, we're creating a point where the y is 0, and we're finding an x. What equation are we going to use for this? Well, you can use either of the two equations that I've boxed up here, but which one looks more simple? Hopefully you're thinking, oh, this slope-intercept form is a little more simple. And you're right, both of them will work, but let's use slope-intercept form. In fact, I'm going to quickly rewrite slope-intercept form just in the middle of these two boxes so we can see, and I'll use it with y. Y equals 3x plus 3. How do we find the y-intercept of this line? Well, you replace x with 0. So I'll do this one in blue. It becomes y equals 3 times 0 plus 3. How do you find the x-intercept? Well, you do the same thing except you replace y with 0. The way you solve each of these is actually a little different too, because in part C, y is already by itself, so we're just simplifying the right side. And when you simplify, you find it's 3. In fact, that was kind of a silly question because this is already in slope-intercept form, and slope-intercept form tells you the y-intercept. It doesn't tell you the x-intercept, though. The x-intercept, I think we probably have to isolate x, unlike on part C where y was already isolated. X is not isolated here. And to isolate, we have to undo what's attached to x. At this point, we know we undo addition and subtraction first, and then we undo multiplication and division. This leaves us with x being equal to -1. All right, last two parts. What is the point on the line given by 3, f of 3? Well, they're asking us to build another point here, and the point is 3, something. The value that we don't know, though, is the value that is found by doing f of 3. We can find f of 3 because we know the equation for f of x. In fact, we know two different ways to write the equation using f of x, but I'm going to stick with the more simple one. So I'm going to stick with our slope-intercept form, f of x equals 3x plus 3. If I want to find f of 3, then that means we replace the x with 3. So 3 times 3 is 9. And of course 9 plus 3 is 12. And so we have now found that the point 3 comma f of 3 is really the point 3 comma 12. All right, last one for this. What is the point on the line such that f of x equals 12? Now here we are again building a point, but we do not know the x. They didn't have an x value there. We're going to have to find that. So what does f of x equals 12 mean? Well, f of x is a fancy way to say the output for a function. They told us that the answer is 12. And so if the answer is 12, that means the y value in this case is 12. So again, starting with f of x equals 3x plus 3, they have told us that the answer is 12, and we want to find the x that creates that answer. Well, to do that, we isolate x. Subtract 3 from each side. 12 minus 3 is 9. Undo the division. And 9 divided by 3 gives us 3. There we go. All right, let's try one multiple choice question just to make sure we get that practice in, and then we have a few more for the day and we're good. Given that a line in the form y equals f of x, again, just a fancy way to say y equals stuff happening to x, passes through the point 1 comma 4 and has a slope of negative 2. Which of the following points then is also on the line? And there may be more than one answer. Well, if we're going to do this and you wanted to figure out what other points are on that line, you have a couple options. Option 1, and I don't recommend this and I'll explain why right now, is you could go ahead and you could graph the point over 1, up 4, like so, and then you could use your slope to go down 2 over 1. And you could continue doing that until you get to each of these points. But the problem is, you might not get to those points fast enough. Now if I reverse the slope and go left 1 up 2, left 1 up 2, left 1 up 1, 2, this looks like the point 0, 6. And so that is a point on our line. And that's important because 0, 6 is an option. So I guess visually we could see that there's at least one point. But it said there may be more than one answer. And do you really want to count to negative 2046? I don't. So is there a different way to do this? Of course. The other way to do this, and again, there's nothing wrong with this, it just takes a while. The other way to do this is to create an equation, because the whole point of an equation is it takes an input and it finds the corresponding output. So let's actually show what I mean here. So I'll just use y to make things easier. We have y equals a slope of negative 2, I'm using HK form, x minus 1 plus 4. Look, there's the equation of my line. Then I am going to try and simplify this a bit because I'm going to be substituting or plugging numbers in, and it's easier to do the math when this is a little more simplified. So let's distribute the negative 2 and combine like terms. There we go. Now what am I going to do with this? Well, this equation takes x's and turns them into y's. So let's go ahead and look at my first point down here that has an x of 10. We're going to go through and say y equals negative 2 times something plus 6. What's the something? Well, that's 10. And we'll see what we get. This is negative 20 plus 6, and negative 20 plus 6 is negative 14. When I substituted in 10, did I get negative 14 as an answer? Yeah. So that point is also on the line. Let's try these last couple. Okay, but you get the idea. Hopefully you can work off ahead. Negative 2 times something plus 6. The something we're substituting in is negative 20. So this becomes 40 plus 6. And I think that is 46. Excellent. We already saw 0, 6 worked. Let's look at this last one, negative 1, 4. I think just by looking at the graph, negative 1, 4 is not going to be on the line. But let's double check. Y equals negative 2 times something plus 6. The something we're substituting in is negative 1. This becomes positive 2 plus 6, and 2 plus 6 is 8. Notice that 8 doesn't match, so D is not on our line. All right, well, On the previous page, we were given a slope and a point, because in order to build the equation of a line, you need the slope and a point. However, what happens if you're not given a slope? A line y equals f of x passes through the points negative 1, comma 1 and 2, comma negative 1. Well, let's go through this. Without graphing, what is the rate of change between these 2 points? And I said without graphing because I have some students that will graph, and they'll say, ooh, negative 1, comma 1, and 2, comma negative 1. They count the rise and the run. And that is okay. However, what if you were given 2 points like negative 501, comma 12, and 2000, comma 777? That would be a little bit harder to count between. And so we do need a second option, but it's an option we've seen before. If we want to find the rate of change, and remember rate of change is a fancy way to say slope or steepness, between 2 points without graphing, we use our slope formula, where our slope formula is that y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. And I do insist that you use the parentheses until you're really comfortable with this, because you're going to make fewer mistakes this way. Promise. Now, how do we do this? Well, we take our 2 points, negative 1, comma 1, and also the point 2, comma negative 1, and we label them. In particular, I always start by labeling them as this is an x, this is a y, this is an x, this is a y. Points always go x, comma y. And then how do we decide which one gets the 1 and the 2? It doesn't matter. Just be consistent. If you give this x the 2, this y needs a 2. Now, I actually start the other way, and I say, well, this is the first x that I came to, so I'm going to call that x sub 1, and it's my first y. This is the second x and the second y. Doesn't matter, though. You'll get the same answer. So we're going to start substituting these guys in. We'll see how we do. Y sub 2, that's got to be negative 1, I think. The y's have to go on the top. Y sub 1 is 1. X sub 2 is 2 in this case, and x sub 1 is negative 1. Working this out, we get negative 2 on the top, and don't forget, 2 negatives make a positive. That's 3 on the bottom. So the rate of change, or the slope, or the steepness between those 2 points is negative 2/3. That kind of makes sense with my graph. It looks like it goes down 2 over 3. Once we found that slope, if we're asked to write the equation of the line in HK form, life gets pretty easy, right? F of x equals, we need our slope first, that's negative 2/3, and then the point. But wait, we have 2 different points, this one and this one. Which one do we use? I mean, is it going to be, if we did this in green, opposite of h is plus 1, keep the k the same, that's a positive 1, or is it going to be f of x equals negative 2/3, and then we do it in yellow, 2 is positive, so it shows up as a negative, and minus 1. Which one's correct? Well, hopefully you're saying, I bet they're both correct. And you're right. HK form can use any point. They gave us 2 points. You just need to pick one. But as a reminder, if they don't give you the slope here, you do have to do the extra step of finding the slope first. If you need to draw yourself some arrows, not a bad thing to remind you when you have a quiz on this next class. All right, part C. With part C, we're asked to write the equation of the line in slope-intercept form. You should be pretty good at this by now. This one is a little bit trickier. I'll do the one in yellow down below. So we have negative 2/3 x minus 2 minus 1. We need to distribute this. When we distribute, and this is why this is a little bit trickier, negative 2/3 isn't going to go nicely with the negative 2 there. But we need to be comfortable with fractions. This is negative 2/3 x. This is negative 2 over 1. And just a little sidebar over here, we multiply fractions straight across. So going straight across, negative 2 times negative 2 is a positive 4. And 3 times 1 is 3. And then this 1 is still hanging out. Now we're not quite in slope-intercept form yet because we need to combine our like terms. The beginning's not going to change at all. This is negative 2/3 x. In order to combine 4/3 and negative 1, we should probably look at that as a fraction. And remember, we can only add or subtract fractions when the denominators are the same. So to make the denominators the same, couldn't I multiply this by 3 over 3? 3 times 1 will make it match the other denominator. So we have still 4/3, but now 1 times 3 is 3, 1 times 3 is 3. 3 over 3 is the same as 1 over 1. It's just written in a different way so that we get common denominators. So f of x equals negative 2/3 x. 4 of something minus 3 of that thing give you one of those, and we are measuring this in thirds. 4/3 minus 3/3 is 1/3. Last but not least, what's the value of the point 19 comma f of 19? Oof, this one looks pretty tough. Well, let's take a look. If we're going to do that, we can either use our original HK or this slope-intercept. I'll use slope-intercept. It looks more simple. We know that f of x equals negative 2/3 x plus 1/3, and they're asking us to find f of 19. So f of 19 equals negative 2/3 x, not x, 19 plus 1/3. Now, hopefully you have a calculator. That's probably the easiest way to do this. However, if you don't have a calculator, we can do it by hand. We'll put 19 over 1. So f of 19, I'll zoom in here. We multiply straight across. Negative 2 times 19 is negative 38. 3 times 1 is 3. Then we have to add 1/3. Well, as we continue out, f of 19, we can have common denominators already. That's excellent. Negative 38 plus 1 is negative 37. I don't think 3 goes nicely into negative 37, which actually might make this easier. I think our final answer will be 19 comma negative 37/3. And you're set. All right, well, let's move away from those fractions and get some nicer numbers. So problem 2. A table of selected values from the line y equals g of x is given in the table below. Now, when they say selected values, they really mean points. Right? For example, this right here is a point. X is your input, and g of x is your output. So this point is negative 5, comma negative 14. And you can see the rest of them. 1, negative 2. I think there are actually 4 different points here. 3, comma 2, and 10, comma 16. So why don't you go ahead and pause this and try part A. Part A wants you to write an equation of y equals g of x in HK form. Okay, so g of x, and you're going to have those 3 blanks for the slope, for the h, and the k. Good luck. Unpause once you're ready to check your answers. Ready, set, go. Well, h and k isn't too bad. The hk is just any point you want, and you have 4 different points. What point do you want? Doesn't matter. I'll take 1, negative 2. Why not? Opposite of h plus k. That's negative 2 though, so let's just keep it as minus 2. And notice you do need those minuses or pluses in here. What about the slope though? It's kind of a bummer. They really didn't give us our slope over here, but luckily we have a formula for that, don't we? We have our slope formula. y2 minus y1 divided by x2 minus x1. And just for labeling purposes, I'm going to do the one in green up here, an x and a y, and then I'll do the one in black at the bottom, an x, second y. Okay, so for clarity, I'm going to cross these out. I'll put them back in a second, but let's get these done. y2 minus y1 divided by x2 minus x1. Alright, these turn into a plus. 16 plus 14 is 30. These turn into a plus. 10 plus 5 is 15. I think 30 over 15, and sometimes people switch these around, but the bigger number is on top. So we can divide both of these by 15. 30 divided by 15 is 2. 15 over 15 is 1. I'm getting 2 over 1, or just 2. And so, we end up with 2 right here. Alright, there's an equation of this in HK form. Remember, you could have used any of these 4 points over here in that spot for the red 2 numbers. Now, they're asking you to find the y-intercept for part B, and I don't want you to do too much work. There's actually a pretty quick, clever way to do this. Now, one way you could find the y-intercept is you could replace the x with 0, right? And you could say y equals 2 times 0 minus 1 minus 2, and you could do the math. That will find the y-intercept. But another way to find the y-intercept is to realize if you put your equation in slope-intercept form, the b is the y-intercept. And slope-intercept form is pretty quick, I think. Right? The first thing we have to do is distribute the 2. It's 2x minus 2 minus 2. And then combine your like terms. Negative 2 minus 2 is negative 4. And so the y-intercept for your equation, the y is negative 4, the x is always 0. All right, we've really gone through the majority of ways that you're going to see a problem presented, a line presented. You might see it in a table. You might see it as 2 points. You might see it as a point and a slope. You might see a line presented on a graph. But regardless, you need to be comfortable writing an equation for any of those situations. What we're going to finish class today with is actually a little faster than what we've done so far. We're going to finish with a couple word problems. Okay, this is the last way you might see a problem, a line presented this semester. So let's begin. Problem 1. The graph below represents the amount of profit in dollars a company expects to make from selling bracelets. According to this model, how much money would the company make if they sell 400 bracelets? Okay. Round your answer to the nearest dollar if necessary, and show all work. Well, let's take a look. Bracelets. We're trying to find the profit, and we know that they're selling 400 bracelets. So where is bracelets? That's on the x-axis. So I think all we really need to do is we need to go out to the x-axis to 400 and figure out what is the corresponding point on our graph. The problem, though, is that this line is going to take quite some time to get out to 400, and I don't know what that y value is going to be. So I think using the graph could be tough. However, bracelets is the input, and we usually use x as the input, don't we? And profit in dollars is the output. That's on the y-axis. So how about we just create an equation for this graph, and then use the equations, input and output, to solve this? Well, if you wanted, you could do HK form. However, looking at this graph, I think it has a pretty nice y-intercept, doesn't it? So let's go ahead and just use mx plus b. M times x with a plus b. Well, it looks to me like the y-intercept down here is negative 6. And then what's the slope, the mx plus b part? Well, this goes up 1, 2, where's the next nice point? It's all the way up here, isn't it? 1, 2, 3, 4, 5 over 2. So to me it looks like our slope is up 5 over 2. Alright, this equation then will take any input you want to throw at it and it'll give you an output. But in our problem, the input is the number of bracelets sold and the output is your profit. So let's go back to the question and see what we're trying to find. We want to know how much money will the company make, that's profit, if they sell 400 bracelets. So we may not know the profit currently, but we do know the number of bracelets we're trying to sell that will tell us the profit. We're trying to sell 400 bracelets. Okay, well, you can use calculator here. However, with this fraction, I'm just going to do the 400 divided by 2 first. 400 divided by 2 is 200. And then I'm going to do 5 times 200, which is 1,000. And then 1,000 minus 6 is $994. And so, if you sell 400 bracelets, you will have made $994, which kind of sounds nice. Alright, let's finish this off with the Disneyland trip. Travis is driving to Disneyland from Reno. He knows that when he had to use the bathroom, he was 2 hours into his trip, and he still had 370 miles remaining. Travis also stopped for lunch 5 hours into the drive and was 175 miles away. This can be modeled by the function d equals f of t, where d is the distance left to Disneyland, and t is the time in hours that Travis has been driving. So distance is found by doing stuff to t. Therefore, the point 2, 380 means 2 is t t is the input, and that means 2 hours into the trip, Travis had 380, that's d for distance, 380 miles to go. So let's take a look. Travis is fond of using cruise control, right? That's what keeps your car traveling at the same speed. He keeps the same speed the entire drive, on average, give or take. And so he knows he can find his speed in miles per hour by calculating the rate of change of his journey. What is Travis's speed? Well, they told us to calculate the rate of change. In order to calculate the rate of change, I think we need 2 points. Did they give us 2 points here? Well, I think they definitely gave us 2, 370. I don't know why it says 380 there. Let's go with 2, 370 and pretend there isn't a typo in the middle of the problem. So we have 2, 370. And then we also have a second point. I think we have the point 5, 175. We do have 2 points. Let's go ahead and find the rate of change, which will tell us the speed for this problem. Okay, so let's say we have our x1, y1, x2, y2. Y's go on top, y2 minus y1, divided by x2 minus x1. Okay. You guys might want a calculator for this part. I'm probably going to use a calculator as well, honestly. We'll save a little bit of time here. And don't forget that Desmos is a calculator too, so if you have Desmos open, you can just type it in there, and that's what I'm going to do. So I have 100. Actually, let's clear all this out really quickly. I have a fraction, and then 175. Oops, nope, top of the fraction. 175 minus 370. Over 5 minus 2. There we go. It looks like we got negative 65. Now, we got a negative slope because Travis is getting closer and closer to the distance. It says in this problem, just make it positive to find Travis's speed in miles per hour. Travis drove 65 miles per hour. All right. Write an equation in HK form that describes Travis's journey. Oh, HK form's easy. I like that. We're going to go back to the negative slope, so negative 65, and then we need a point. We have a blue one and a green one. Doesn't matter. I'll use the blue one. T minus 2 plus 370. To find the total distance from Reno to Disneyland, we can just look at how far Travis still has to drive at a time of 0. A time of 0 is when he's starting out. And we have an equation that turns times into distances. So let's see how far Reno is from Disneyland. We know that our distance here is what we're looking for, and we have negative 65. We know the time. The time is 0. 0 minus 2 plus 370. I'm just using my equation from earlier. From here, we just need to go through, and I'm just going to follow PEMDAS. 0 minus 2 is negative 2. 65 times negative 2, I think, is 130. You can check me on the calculator. And then 130 plus 370 seems like it is 500. Okay? And so we find that the distance from Reno to Disneyland is about 500 miles. And that is a true fact, by the way. I tried to look up these numbers and make it fairly accurate. Last but not least, Travis arrives at Disneyland when the distance equals 0. That means there's 0 miles left to go. Approximately how long did it take him to get to Disneyland from Reno in hours? Well, we have an equation that with distance and time. We know the distance is 0. And I think if we solve this equation for t, it will tell us how much time it took Travis to get there. Okay, so we need to distribute negative 65t plus 130 plus 370. Combine your like terms, negative 65t plus, and then we saw this earlier was 500. We're not done yet. There are 2 numbers attached to t. Negative 65 is multiplying, 500 is adding. So we should probably subtract from both sides first. This gives me negative 500 equals negative 65t. And I have run out of room, so I'm going to use this space up over here. So let's try again. Negative 500 equals negative 65t. And let's finish off by dividing both sides by negative 65. Okay, we might want to go through and do this on our calculator again. I'm going to do the same thing. So we have negative, I've already forgotten, 500. Let's try this again. Negative 500 divided by negative 65. Remember we always go out to 3 decimal places, 7.692. And then the time was in hours. So it took Travis about 7.692 hours to get out to Disneyland. All right, well, thank you for tuning in for today. We practiced a whole bunch of different ways to write equations. The very last thing we have to do in this unit, it's very short, lesson 3.4, is now that we know how to write the equations, we're going to start comparing equations and comparing graphs. So we're going to be given 2 graphs, and we might say which one has a steeper slope, a bigger y-intercept. And really what we did today is going to be integral to understanding how to compare those equations. Thank you as always for tuning in. I hope you got something out of today, and I will see you guys back next class for lesson 3.4.